Welcome to the wonderful world of electron configuration.
Today, we're going to learn how to find out where electrons go without actually shrinking ourselves down and looking.
Electron configuration is a way of expressing the probable location of an electron within an atom. Why don't we find out more?
Let's jump right into the magical adventure
In science!
Rules and principle. Now, we've got some rules to go over with you. You better brush up on German to remember these scientists. The Heisenberg uncertainty principle says that we can't determine the position and momentum of an electron at the same time.
Aufbau's principle tells us that an electron will occupy the lowest energy orbital that can take it.
The Pauli exclusion principle states that no two electrons in the same atom can have the same set of 4 quantum numbers.
Hund's rule tells us that orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron.
Types of configuration. There are three different types of electron configuration: orbital configuration, electron configuration, and noble gas configuration. Orbital configuration.
Orbital electron configuration expresses the probable location of an electron within an atom.
All you have to do is follow the yellow brick road.
The number 1 through 7 indicates how far away the electron is from the nucleus.
A smaller number indicates how many electrons that particular orbital can hold.
The S, P, D, or F indicates which type of orbital the electron is in.
Let me demonstrate by showing you how the electrons in oxygen look.
Always make sure you write down the number of electrons that you're configuring.
So oxygen has 8 electrons, so I always write down 8e negative. And I know we always start off with a 1s orbital. So 1s, down, 2s, up, and then down. And then we go to 2p, which has 3 spots. Then you always have to fill ups before you can fill the downs. And there we have 8.
Now let's go over the shorter way to write an electron configuration.
For this one, you just have to write the orbital and the number of electrons on the orbital. No arrows needed.
Let's go over the configuration of chlorine in the shorter form.
Again, we always have to write down the number of electrons, 17e minus. And now we can just do 1s2, 2s2, 2p6, 3s2, and then we go to the 3p orbital, but we don't fill that up, and that all adds up to 17.
Noble gas configuration. Noble gas configuration is probably the easiest of the 3 different configurations because it involves the least amount of writing.
You just have to find your element and the noble gas that's in a row above it.
From there, write the symbols for the noble gas in brackets and start on the nearest s orbital.
We'll use zinc as an example, which is in the 4th row. So we go to the 3rd row and find that noble gas in this row is argon.
Write down Ar in brackets, and since zinc is in the 4th row, we start in the 4s orbital and continue by using electron configuration or orbital configuration until we have completed the configuration of every electron.
Let me show you how to do this in the noble gas configuration. So we already know that zinc has 30 electrons. 30, not 3. And then we go to argon, which is 18, as we already know. From there, we have 4s2 and 3d10, which equals 30.
There are 7 special elements that don't quite fit in with the others in terms of electron configuration.
These elements ignore both Hund's rule and the off-ball principle. Or, as Mr. Lawsey would say, they fight the power.
These certain elements send one electron from their s orbital to fill their d orbital.
The elements in question are copper, silver, gold, platinum, palladium, chromium, and molybdenum.
Here we'll see a configuration of copper, and how we have to take one electron from the s orbital to place it in the d orbital.
So for this, I'll use the electron configuration method. We know that copper has 29 electrons, and start off 1s2, 2s2, 2p6, 3s2, 3p6. Now we have a 4s, but this is only 1 because it transfers into 3d to fill the d with a 10. So whereas this should have 2, it ends up with 1 because it goes over here.
That was our review on electron configuration. Remember it well, and good luck on the final.